Hello, Math 1. Day 2 of remote learning. Straight ahead. We're basically doing one goal today. All right, and again, it's a pre-algebra skill. It's finding the greatest common factor, except we're introducing variables here. And I'm going to use prime factorization, the skill we built up, one of the skills we built up in yesterday's video. So, what I'm going to ask you guys to do right away is just, and by the way, this is sort of like the baby steps for how to find the greatest common factor. In a week or two, I would expect you guys to be able to do this without using prime factorization, but for this lesson only, let's use prime factorization to prove ourselves on this. Okay, so we've got 42xy, that monomial expression, as well as 56x squared y. Now the goal is to try to figure out what the greatest common factor is between these two, which means what's the biggest monomial that both of these divide, okay? So sometimes it's just a matter of saying, look, what are all the prime factors that 42xy has? What are all the prime factors that 56x squared y has? And then all we do is just match them up and see what we get. So 42xy. You guys might need to use the factor tree for some of these. Some of them you might be able to do in your head. I'll just show you the factor tree way so that there's no confusion. So 56 and 42. Remember, I talked about just cutting things in half when you can, since 2 is a prime number. So 42 is 2 times 21, and 21 is 3 times 7. So not too big of a beast on this one. It's just 1 times 2 times 3 times 7. And don't forget the variables tagged along at the end. And you've got your first monomial factored. Second part, 56 is, half of that is 28. Since it's even, we can take half of that, 14. Since it's even, we can take half of that, which is 7. Once you remain with a prime number, you're done in the right-hand column. So 2 times 2 times 2 times 7 with a 1 at the end, or with the 1 at the front. So 1 times 3 2's and a 7 with 2 x's and a y. So now, the shared factors comprise or make up the greatest common factor. So the greatest common factor is 1. So I'll use GCF to abbreviate greatest common factor. That's usually pretty reasonable. Yeah. So it's 1. They also share a 2. So I'm multiplying as we move along with the greatest common factor. So 1 times 2 times 7, they share an x, they share a y. So your greatest common factor is 14xy. Let's try it with number 2. You've got negative 64a squared b, and then negative 27cd cubed. All right, so again, we're just going to try to map out the greatest, or not the greatest common factor, but the prime factorization. So put a negative 1 at the front end like we talked about yesterday, times 1. 64, that breaks down into 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So we've got 1, 2, 3, 1, 2, 3, 4, 5, 6 2's. All right, and I think we're going to run out of space here, so I'm going to move this here a little bit, times AAB. And then 27, much easier task. That doesn't divide 2, but it divides 3. 3 times 9 is 27, and 9 is 3 times 3. By the way, if you feel like I'm going too quickly with the breaking down of each number, just remember that you will be able to use a calculator if you need to make the calculations less burdensome. So take that for what it is. So you got a -1 out front to start, and then put that other 1 in there as well. 3 times 3 times 3 goes in there. Then you got a C and 3 D's. And then we ask ourselves, what are all the factors that they share? They share a -1. They share a 1. The greatest common factor, therefore, is -1 times 1. They don't share any 2's. They don't share any A's, B's, or C's, or D's. So that's it. It's just -1. Why don't you guys pause the video now and try to do number 3 on your own? All right, checking out number 3. (16m to the 3rd n squared, -48m to the 5th n to the 4). If you want to try to do some mental math on something like this, go ahead. Like 16, 2 times 8, 2 times 4, 2 times 2. So there were 4 2's in that. But you know what? I think I'm just going to stick with the factor trees on our first try, instead of trying to do everything in our head. So there's 1, 2, 3, there's 4 2's. So 2 times 2 times 2 times 2, 3 m's and 2 n's. And then 48. 48 is actually just 3 times 16. So if you want to, throw the 4 2's down here and then put a 3 outside of that. If you want to do it the traditional way, though, 2 times 24, 2 times 12, 2 times 6, and then 2 times 3. So it's 1 times, well, -1 times 1, because we got a negative out there. 2, 2, 2, 2, 2, 3. 1, 2, 3, 4 2's and a 3. And then we got 5 m's. And then 4 n's. All right, they share a positive 1. They share a pair of 2's. They share more 2's. They share all the pairs of 2's. All right, and then they also share 1m, 2m's, 3m's. Let's just say they share a lot of factors. Okay, so it should be a much larger, a greatest common factor than what we had from the previous two. So the GCF is 1 times 2 times 2 times 2 times 2 times m times m times m, and then 2 n's, which comes out to be 16 m to the 3rd n squared. All right, so not too tricky to start with this. I should probably do example number 4 just in case it's like a weird special case. I'm not sure. There must be a purpose for it. Let's check it out. All right, you know what? I'm actually going to erase this stuff up here. I want to be in the light. All right, so we got 108x squared for my first term, 39x cubed y squared for the second, negative 51y cubed for the third. And here we go. So 108, half of that's 54. Take half of that again, it's 27. Divide that by 3, the 9 divides by 3. So you've got 1 times 2 times 2, and then a trio of 3's. 3 3's. And then x squared is x times x. 39 is our next one that we have to break down. This one doesn't divide 2, but it does divide 3. 3 times 13 is 39. 13 is a prime number. So we're done with the prime factorization. It's 1 times 3 times 13. These are the only two prime factors. And don't forget the variables. Negative 51. I'm just going to put that negative 1 right there, right away in case I forget. 51, that's another one that divides 3. 3 times 17 is 51. So since 17 is a prime number, we've got our two primes. So they share a 1, they share a 3, and this one has 3 y's tagged on the end of it. Now, it's important to make sure that all 3 terms have to share. So you can't just start circling x squareds for the first 2 because the first 2 share it. And you can't just start circling y's on the second 2 because the second 2 share. All 3 have to share. So that's it. The GCF is 1 times 3. Now, one example I want you to be aware of is when you have a group of monomials that share nothing but 1. So you might want to jot this down somewhere. If a group of monomials only share a factor of 1, so if the only number or variable expression, the only thing I circled was the 3 1s here, if that was the only thing, then the group is considered prime. And you'll see how that relates more to prime polynomials when we actually start what's called factoring a polynomial. All right, I hope this was super helpful for you guys. Check Google Classroom to see what the actual assignment is, and good luck.